This is an old school hold down system that was popular 40 plus years ago. It's a power tool accessory used to hold down workpieces during operations. These once popular items were all but replaced by this style featherboard several decades ago. While these types of featherboards are fantastic, they do have some limitations. And I'm wondering if on occasion going back to the old style hold down might solve some of those problems.
I'm going to cover this timeline quite quickly. If you want more information regarding the history of the plastic featherboard, please see Scott Markwood's video on the topic. I will place a link in the description. In 1933, the Delta Company filed a patent for an adjustable shaper fence, which included a hold-down mechanism. The assembly included two metal springs for holding the workpiece against the fence and down to the table. And here is Delta's shaper fence in real life, including the metal hold-downs. In this 1941 issue of the Deltagram magazine, Delta advertises the metal spring hold-downs for sale as a separate accessory. And in this 1953 Delta user manual, the spring hold-downs are used to hold a workpiece against the table saw fence during a dadoing operation. The manual also illustrates the miter gauge hold-down. Here is a better picture. We will discuss this tool a little later. In the 1955 edition of Power Tool Woodworking for Everyone, Shopsmith version of the spring hold-down illustrates a dadoing operation on the table saw and an overhead shaping operation. It makes sense that the Shopsmith version of the metal hold-down would hit the market in the early 1950s, since, according to Google Patents, the Delta patent expired in 1951. Fast forward to 1982, when Shopsmith filed a patent for an adjustable featherboard, and based on the illustration, we can tell that this is the widely popular plastic finger featherboard. With the patent filed, Shopsmith was free to advertise the featherboard in a 1982 issue of Hands-On magazine. Here, the featherboard is included in an introductory offer of the Shopsmith safety kit. The 1985 The Complete Book of Stationary Power Tool Techniques shows both the Shopsmith safety kit and the metal spring version of the hold-downs. These hold-downs are likely the Craftsman variant, which we can see in the 1981 catalog shown as number 5, hold-down attachment set. This user manual is the most recent dated document I can find regarding the metal spring hold-down. And in the 1989 edition of Power Tool Woodworking for Everyone, the metal spring hold-down is entirely replaced by the plastic adjustable featherboard. Taking another look at the timeline, we can see that the metal spring hold-down enjoyed some degree of popularity between 1933 and 1987. That's almost 55 years. But after the introduction of the plastic featherboard, the metal spring hold-down all but disappeared from the market by the end of the 1980s.
Before I jump in, I want to understand what each of these systems do and the differences among them. I found a very important feature that these guards claim to do that this system does not, and it has to do with kickback. Now, I'm not an expert in table saw safety. In particular, I'm no expert in kickback. So I'm going to send you off to an article that I believe is a reputable source. It's a 2014 article in Woodcraft magazine by Paul Anthony. I'll leave the link in the description. I've got my Shopsmith set up with the shaper fence and the speed increaser for under table shaping routing. I do have the machine unplugged and I don't plan on running it, so I've not installed any of the guards. In this setup, we encounter the first limitation of these plastic feather boards. If I have a relatively narrow workpiece, I'm just fine. I can feed the workpiece through and it has plenty of support. And there's some resistance to kickback as well. However, if I have a wider workpiece, such as this one, which really isn't that much wider than the first piece I showed you, the featherboard won't work. And that's because the featherboard attaches to the table in the miter slot. And so I have a maximum capacity. There just isn't enough room between the fence and the miter slot. To overcome the width issue, I would need to move the featherboard back on the table and then use some sort of C-clamp to attach the board to the table. The second issue I run into with the shaper fence setup is related to keeping the workpiece held down to the table while I feed it through. These featherboards work by attaching to the miter slot. There's no reciprocal slot on top of either of these fences. Power Tool Woodworking for Everyone does suggest making a scrap board with a dado in it, matching the width of the bar here. Then you could affix the piece of wood to the top of the fence, either here or here, and then put the bar into that dado. Yet another option for holding the workpiece down to the table is this system, which is designed to attach to the table saw fence. I could just simply take 2 screws and screw them down to the slots and into the wood of this fence, but that's going to have a thickness limit to it. Here's the system set up with the spring hold downs. It feels very confident. There's quite good pressure both down and into the fence on this. It looks like a lot of this stuff is in the way, but with a push stick, there would be no problem feeding that through. And then of course I could add additional hold downs over on this side. One thing to point out here is that this system was designed to work on a smaller table. Because this table is bigger, I have a limitation of about 130 millimeters width. But let me try moving this post to the front of the table and see what it looks like. So now with the hold down mounted to this side of the table, I can arrange the springs to accommodate a very wide board and probably a board as wide as the table. This is the clamp and post that attaches the set to the table in the vertical position. I'm curious if I can take this post and attach it to this miter slot T-nut. Yes, I can. So that gives me the flexibility to attach this post anywhere I can fit this miter slot T-nut. I've got the Shopsmith set up here in overhead routing / shaping mode, and it's really all the same benefits and limitations between the plastic feather guard and the metal spring hold downs as with under table routing shaping, except for this one attachment that attaches to the quill. Let me show you what that looks like. The machine is unplugged in this scenario, and by the way, in this configuration, I reverse my feed direction. It now goes this way. And I've got the featherboard set up with the correct orientation to account for that. So this featherboard will do a good job of pushing the workpiece down as I feed it through the cutting operation. However, there is a height limitation. For example, I would not be able to use this featherboard if the workpiece were in the vertical orientation. There's just not enough clearance, and I've maxed out how high I can go here. At the table saw is where our kickback conversation really heats up. Once again, I'm going to refer you back to the Paul Anthony article, which really contains what I consider some expert information. He breaks down kickback into 2 categories. The first category he refers to is when feeding workpieces in a rip cut and the workpiece getting caught between the fence and the blade and ejecting backwards. Of course, I can mitigate that risk by not standing here, but standing off to the side. The other mitigation I have available that's built into my saw guard are these kickback paws. They don't eliminate kickback, but they reduce the consequence of kickback by acting as a brake on the motion of the wood. I do have a little bit of grabbing power here with these featherboards, and that's the primary feature that these featherboards have that the steel spring hold downs do not, is they add some kickback mitigation. Now, these featherboards also help prevent kickback, but the spring hold downs help prevent kickback as well. And that's more related to the second type of kickback. So I've set up my table saw for the second type of kickback that Paul Anthony refers to in his article. I've removed the guard and I have not installed the riving knife. I have the fence installed, but no featherboards or anything keeping the workpiece held to the fence or down to the table. Just going to use my hands. Now, I'm not going to plug in the table saw because that would, in my opinion, would be very dangerous. Let me try to explain this type of kickback. The visual demonstration is we're going to push forward here at the end of the board. See what's happening? There's almost no way to push this board forward without it leaving the fence. And whether or not that's pushing here along the fence, which is what you would want to do if you didn't want to cut your fingers, or if that's pushing in the middle, it still wants to wander from the fence. Particularly when you have forces from the blade pushing this way and your hand pushing this way, it will want to twist. So the second type of kickback, what happens is the workpiece actually climbs on top of the blade like so, and then it violently shoots it back like this. And there's lots of videos on YouTube that explain that, including a frame-by-frame illustration in the Paul Anthony article. Several options for mitigating this circumstance. With the help of a featherboard, that's going to prevent the board from rotating as I push down here. So it's going to keep this leading edge against the fence. That'll mitigate the likelihood that the board twists into the blade, is lifted by the blade, climbs on top of the blade, and is ejected out. Even more protection, I can add this feather guard. It will hold the workpiece down, again, mitigating the likelihood that this board will climb on top of the blade and be ejected this way. The spring hold downs will provide all of those same features. The only feature that the spring hold down won't provide is the resistance to the backward motion if a kickback occurs. Admittedly, that's a pretty big feature missing from this system, which is the resistance to backward motion if a kickback occurs. On the other hand, if I have all my other safety equipment installed, a kickback is so unlikely to occur that I may not really need it. And with the type of kickback that this prevents, which is the kickback that goes directionally backwards, the other way I can mitigate that is to stand to the side. So I have to think fairly carefully about which circumstance I want to use this system. So here I've set up a scenario where I might want to use these spring hold downs. And this is a scenario where using one of these is not an option because we have it fitting into the miter slot and the board is too wide to feed through it. Now, as discussed before, there's always the option to C-clamp it to the side of the table, but at that point, I get a little suspicious whether or not this would remain in orientation under a clamp sufficient enough to add the kickback protection. So in this scenario, well, you know what? Actually, that's digging into the side of that wood. You know, none of the documentation claim a benefit of preventing wood from going backwards, but yeah, there's a little bit of a rough spot that's catching on. Okay, I'm not going to rely on that. I'm going to rely on the documentation, which doesn't mention anything about that feature. But I still have my kickback prevention features in place. And I also have my accuracy and safety features in place as well. By accuracy, I mean because the workpiece is held against the fence, I'm going to get a smoother, cleaner, more accurate cut. Again, the table saw is unplugged. I'm not going to turn it on, but I would feed the workpiece in like this. This spring would hold the workpiece against the fence. This spring would hold the workpiece down to the table. And with the riving knife and kickback paws installed as part of my saw guard, and with this feather board installed, I think that the likelihood of kickback in this situation approaches zero. That's just my opinion. So I would continue. There's plenty of room over here to feed the thing through and safely make the cut. The next feature I'd like to investigate regarding this Shopsmith universal hold down system is in relation to these figures here. And you can see that this is very similar to the Delta miter gauge hold down system that I showed a little bit earlier. In order to set that system up, I need to poke a hole in the miter gauge bar as per the instructions. I've got a fairly well used and abused Shopsmith miter gauge here that I'm willing to take a risk drilling into. So let me go ahead and make that hole, set up the system, and get back with you and show you what it's all about. Okay, I've converted the Shopsmith universal hold down system into the miter gauge hold down. So in this configuration, it's very similar to the Delta variant of the miter gauge hold down, except it only has one hold down instead of the two. In order to set that up, I had to remove the Shopsmith safety grip. It also includes a hold down, but you only have flexibility to extend this far in front of the face of the miter gauge. However, with this system, I could move this hold down anywhere along the length of this bar. So for example, if I wanted the hold down much closer to the leading edge of the cut, I could do that. I kind of like that. That does feel pretty secure. Well, I have to admit, I'm torn about this system. I know for sure that whenever I can use one of the modern feather guards, I'm going to. But these guards have a limited range, while this system is very flexible and can handle a wide variety of workpiece sizes. So in cases where this feather guard just doesn't reach, I might consider using this, but I'm not convinced. I think the best thing to do is live with it for a while and try it out a few more times. Well, that does it for this woodshop nerdery video. I hope to see you in the next one. Bye.